Servo Altimeter. Each pilot has one servo altimeter positioned to the right of their respective primary flight displays. Power is controlled through the avionics master switches, switch 1 for altimeter number 1 and switch 2 for altimeter number 2. The servo altimeters are controlled electronically from their respective air data computer. General description. The servo altimeters are of the counter-pointer type. The pointer makes reference to a 1,000-foot scale around the outside of the dial, which is divided into 100-foot units and furthermore into 20-foot units. The counter has a range of between -1,000 feet to +50,000 feet and reads to the nearest 20 feet. The front of the display contains two baroscales, one in millibars, one in inches of mercury. Both baroscales are set to the correct barometric reference using the baro setting knob at the bottom left-hand corner of the instrument. The baroscale range is 745 to 1049 in units of 1 millibar and 22.00 to 30.99 in units of 0.01 inch mercury. When the altitude is below 10,000 feet, a green flag covers the tens of thousands digit in the counter. In case of negative altitude, a black flag reading neg in white covers the counter. A system failure is indicated by an orange OFF flag covering the counter readout. An amber ALT annunciator provides visual warning of approach to or departure from a selected altitude. The altitude is selected on the MCP. Whenever the ALT annunciator illuminates, a 2-second audio tone is heard. When changing level to a newly selected altitude, the annunciator illuminates at the 1,000 feet to go point to remind the pilot to monitor the level off maneuver. The annunciator extinguishes as the aircraft passes within 300 feet of the selected altitude. Once the selected altitude has been acquired, the annunciator will flash if the aircraft deviates more than 300 feet vertically. Summary. This animated example summarizes the logic of the altitude alerting function of the servo altimeter. A white reference bug at the edge of the scale is controlled by the knob in the bottom right-hand corner of the instrument. Normal operations. Ensure that the altimeter pointer and counter of the servo altimeter move according to a change in the baro setting. Abnormal operations. With any servo altimeter system failure, the orange OFF flag is shown in the counter window. There are three possible causes: servo altimeter failure, loss of instrument power, loss of valid data from the air data system. In the case of an air data computer failure, the altimeter can use data from the remaining air data computer. This is achieved by selecting the air data computer transfer switch to either both 1 or both 2 as appropriate. Standby altimeter airspeed indicator. The instrument is located to the right of the captain's navigation display and is totally mechanical in operation. The standby altimeter and airspeed indicator provides backup altitude and airspeed reference even at the emergency power level. General description. The standby altimeter airspeed indicator is a combined instrument displaying altitude and airspeed. The power supply to the standby altimeter airspeed indicator is only for illumination and an internal vibrator that improves accuracy by preventing stiction, friction between gearing. The standby altimeter airspeed indicator is not supplied by an air data computer. Instead, it uses pitot static supplies from sensors P3 and S3. The standby altimeter is of the counter pointer type. The pointer makes reference to a 1,000-foot scale around the outside of the dial, which is divided into 100-foot units and furthermore into 20-foot units. The 100-foot units are marked 0 to 9. The counter has a range of between -1,000 and +50,000 feet and reads to the nearest 1,000 feet. In flight, the standby altimeter indication will differ from the servo altimeter indication, since standby is uncompensated by air data computer. The front of the display contains two baro scales, one in millibars, one in inches of mercury. Both baro scales are set to the correct barometric reference using the baro setting knob at the bottom left-hand corner of the instrument. The baro scale range is 745 to 1049 in units of 1 millibar and 22.00 to 30.99 in units of 0.01 inch mercury. When the altitude displayed is below 10,000 feet, A black and white crosshatch flag covers the tens of thousands digit in the counter. In the case of negative altitude, an orange flag reading neg covers the counter. The airspeed indicator is a rotating drum type that contains a speed scale of between 60 to 450 knots. The current speed is read off the scale by a fixed pointer. Normal operations. Ensure that the standby altimeter pointer and counter move according to a change in the baro setting. Abnormal operations. There are no fail indications for the standby altitude airspeed indicator. Outside air temperature gauge. The outside air temperature gauge is positioned at the bottom of the first officer's instrument panel. General description. The outside air temperature gauge is supplied with temperature information from its own dedicated probe situated on the lower left-hand side of the nose. The scale of the gauge is minus 60 degrees C to plus 60 degrees C. The gauge indication is not corrected in any manner. Indicated outside air temperature, IOAT, is shown. This can be converted to static air temperature by reference to a graph in the aircraft flight manual. Normal operations. On the ground, check that the outside air temperature gauge is reading ambient by comparing with the ATIS temperature. Abnormal operations. A system failure is indicated by the pointer permanently indicating minus 60 degrees C. Standby attitude indicator. The standby attitude indicator is situated on the captain's instrument panel. The indicator uses a self-contained gyro that is powered from emergency DC. General description. The standby attitude indicator provides pitch and roll reference, slip indication, and ILS deviation. The standby attitude indicator provides pitch and roll attitude with horizon reference on a two-colored sphere against a split Q aircraft symbol. The horizon is shown as a white line dividing the brown earth reference and the cyan sky above. Pitch divisions are marked out every 5 degrees and are numbered every 10. A roll indicator reads against a scale inside the top of the periphery of the display. The scale is marked at 10, 20, 30, 45, 60 and 90 degrees. At the bottom right hand of the instrument is a fast erect knob. This should be pulled and held until the indication has aligned. A slip indicator is fitted to the bottom of the instrument. ILS deviation information from ILS number 1 is shown by cross hairs, split Q. These are only displayed if an ILS frequency is selected on the captain's VHF navigation controller. It is important to note that the crosshairs display shows deviation and is not a flight director. With no ILS frequency selected, the crosshairs are biased out of view. Normal operations. Prior to departure, the standby attitude indicator is compared against the other horizon information. Abnormal operations. A failure is indicated by a black and red fail flag that will appear for any of the following reasons. The internal gyro has not run up to speed. Failure of the whole instrument. Failure of the instrument's power supply. At the left side of the display, a red GS flag will appear for any of the following reasons. Loss of a glide slope due to a failed receiver. Instrument fault. Weak signal or power failure. At the bottom of the display, a red LOC flag will appear for any of the following reasons. Loss of a localizer signal due to a failed receiver. Instrument fault. Weak signal or power failure. Distance bearing indicator. The distance bearing indicator displays heading, VOR and ADF radio bearing, and DME indications. Each pilot has a distance bearing indicator positioned to the left of their navigation display. Distance bearing indicator number 1 for the captain, and distance bearing indicator number 2 for the first officer. Power to the instruments is switched through the avionics master switches. Only distance bearing indicator number 1 is available at the emergency power level. The heading information for distance bearing indicator number 1 is normally supplied from IRS number 2, and distance bearing indicator number 2 is normally supplied from IRS number 1. General description. The distance bearing indicators contain a 360-degree compass card to provide heading information. Remember that the heading displayed on the distance bearing indicator is taken from the opposite side's IRS. This enables each pilot to monitor the aircraft's 2 heading references, because the adjacent navigation displays use on-side IRSs. Each distance bearing indicator has 2 pointers to provide bearing indications to either a VOR or NDB. A dashed single shaft pointer relates to either VOR number 1 or ADF number 1. A double shaft pointer relates to either VOR number 2 or ADF number 2. Switches at the bottom corners of the distance bearing indicator allow bearing source, ADF or VOR, to be selected for the pointers. The left switch is for the single shaft pointer, and the right switch is for the double shaft pointer. The switches are selected horizontally inwards for ADF and vertically upwards for VOR source. The DME distances for both DME number 1 and DME number 2 are displayed at the top of the distance bearing indicator. DME will be covered in greater detail later. Normal operations. Testing of the distance bearing indicators is performed as part of the normal pre-departure checks by checking heading validity and comparing adjacent beacon bearing and distances. Abnormal operations. Heading reference failure is indicated by a red heading fail flag at the top of the display. The compass card will be frozen. No action is possible. The attitude heading transfer switch does not affect the distance bearing indicators. At the emergency power level, distance bearing indicator number 1 will automatically have its heading reference transferred from IRS number 2 to IRS number 1. This ensures that the captain maintains a heading reference at the emergency power level. With the failure of the selected VOR or ADF system, a red flag will appear and the pointer will park horizontally. A red flag with a single shaft on the left of the instrument indicates the failure of ADF number 1 or VOR number 1. A red flag with a double shaft on the right of the instrument indicates the failure of ADF number 2 or VOR number 2. When a radio beacon is out of range or the signal is too weak for use, the radio pointers are parked horizontally. The fail flags are not shown. Loss of power to the distance bearing indicator will cause all 3 fail flags to appear simultaneously.